Next is problem 10, exercise page 207. The problem A is let f of g denote a function which is analytic in some annular domain about the origin that includes the unit circle g is equal to e to the I pi, where pi is greater than or equal to negative pi and is less than or equal to pi. By taking that circle as the path of integration in expressions 2 and 3, in section 66, for the coefficients an and bn in Noether series in powers of g, show that the following holds. F of g is 1 over 2 pi times integral negative pi to pi f of e to the I pi d pi plus 1 over 2 pi times summation n is equal to 1 to infinity integral negative pi to pi f of e to the I pi times, here first term is g over e to the I pi to the power of n plus e to the I pi over g to the power of n d pi when g is any point in the annular domain. Okay, before the check the solution, we first review the definition of Noether series. For a given function f of g can be expressed by this form as a Noether series. Summation n is equal to 0 to the infinity an times g negative g naught to the n plus summation n is equal to 1 to the infinity bn over g negative g0 to the n. Yeah, this right hand side can be rewritten by this for the case of n is equal to 0, then this part will be 1, then we get a0 here, and then the remaining things, summation n is equal to 1 to infinity an, the same here you get, then this part is the same. Also there is another formula for Noether series. F of g is equal to summation n is negative infinity to infinity cn times g negative g naught to the power of n. Okay, where cn is 1 over 2 pi I times integral along to c f g dg divided by g negative g naught to the n plus 1. This summation can be decomposed 3 parts. C0 and this part, positive power and negative powers here. Here Cn and C negative n are used for each part. So remember this formula. Then f of g can be expressed by this as a Noether series. Summation n is equal to negative infinity to infinity cn times g to the n. Here, this part can be decomposed into this three parts, C0 and positive powers and negative powers here, as we checked just before. Then here C0 is equal to a0. a0 is 1 over 2 pi I along integral along to c. Then a0 n is replaced by 0 here. Then 1 over fg over g negative g naught. Then we consider contour c. In the problem, we consider unit circle here. unit circle here, g is equal to e to the I pi, where pi is greater than or equal to negative pi and less than or equal to pi. So we apply this condition to the integral, then we get this. For g is replaced by e to the I pi in the formula here and here and here. We consider the origin center as a center of the circle. So g naught is 0. So we only consider g in the denominator, g to the n plus 1. Then we get this form. And also this and this for the positive powers and negative powers. Okay, then we compute this. The problem just, fg is equal to, like this. So we get this, from this directly. By cancellating, here, cancel here, e to the I pi, and I here, then we get this, f of e to the I pi. And similarly, we cancel I, and e to the I pi here, I pi, then e to the in the denominator here, and factor f of e to the I pi here. Then the remaining part is 2 positive and negative parts here from this and this. So the problem solved as you wanted. Okay, next is B. It is to write u of zeta is equal to real part of f of e to the I zeta, and show how it follows from the expansion in part A that u of zeta is equal to 1 over 2 pi times integral negative pi to pi u of pi d pi plus 1 over pi summation n is equal to 1 to the infinity integral negative pi to pi u of pi cosine n zeta negative pi d phi. This is one form of the Fourier series expansion of the real valued function u of zeta on the interval. Zeta is greater than or equal to negative pi and less than or equal to pi. The restriction on u of zeta is more severe than is necessary in order for it to be represented by a Fourier series. Okay, let's check it in detail. For g is equal to e to the I zeta, because we consider a unit circle in the problem. You already know it. Then we have this. In the problem A, we get this. U zeta real part u zeta is equal to real part of f of e to the I zeta. Okay. So we consider this. This to compute real part of this this in the denominator e to the I pi, and also g is e to the I zeta, and plug in this e to the I zeta negative I pi and to the power of n. So we get this. And from this, because g is equal to e to the I theta, then negative I pi negative I theta, then to the power of n, we consider, if we consider, then we get this. So we know the Euler formula. E to the I theta is cosine theta plus I sine theta. So real part comes from this, which is exactly this. So from this we get this cosine n theta negative pi, and from this we get this cosine negative n times theta negative n, theta negative pi, because cosine function is even function, so this is exactly same, just cosine n theta negative pi, so which is the same here. So we have two of them, so result is 2 times cosine n times theta negative pi here. Hence u of theta is real part of f of e to the I theta. E to the I theta, okay. Real part of f of e to the I theta is, like this. Compute, this 1 over 2 pi and integral plus 1 over pi summation,